Let's take a look at the apply the remainder and factor theorems note sheet. And let's start with example 1, use polynomial long division. So we're going back to the basics of long division from elementary school. And this is what we're dividing by, so it's going to be the thing that goes on the outside of the division box. And then the things we're dividing is going to go on the inside. So we start with x to the fourth, then x cubed, and then we don't have an x squared, so we're going to use a placeholder. That should look familiar. And then we have x, and then our constant. And then to divide, you are going to actually start by dividing this by this. And so we're looking at 3x to the fourth divided by x squared, which is 3x squared. So we divided. Now we are going to multiply. And so we're going to actually multiply 3x squared times x squared, 3x to the fourth, 3x squared times negative 3x, negative 9x cubed, and 3x squared times 5. And then, third step, we're going to subtract. I'm going to do this in red because when we subtract, if you think about how I always talk about this in class, subtracting is adding the opposite. So we're actually going to do the opposite of each one of these and then just add. And so these cancel. We have 4x cubed and negative 15x squared. Then we're going to bring this down. And then we're going to do this divided by x squared, which is 4x. So we've started this whole thing over again. We've divided, now we're going to multiply. So 4x times x squared, 4x times negative 3x, 4x times 5. And then we're going to do the opposite of those. Cancels. Negative 3x squared minus 16x, and then we're going to bring this down, minus 6. We're going to do negative 3x squared divided by x squared, which is negative 3. And we're going to multiply negative 3 times x squared, negative 3 times negative 3x, positive 9x. Negative 3 times 5 is negative 15. And then we're going to do the opposite. So these cancel. We have negative 25x plus 9. Negative 25x cannot be divided by x squared. The power is smaller than x squared. So that means that this is going to be our remainder. And so we are going to do plus, and then we're going to put our remainder over what we are dividing by. And so this right here is our answer. Okay, let's do another one of those. And then I'll show you the other method for long division, which is actually quite a bit easier. So same thing, we're going to take this and put it on the outside. And then what we're dividing goes on the inside. X cubed, x squared, x, and constant. Start here, divide x cubed by x, that's x squared. And we're going to multiply x squared times x squared times negative 2. Change your signs. These cancel. We have 7x squared minus 7x. We bring this down. We take 7x squared divided by x, which is 7x. Then multiply 7x times x, 7x times negative 2. Change the signs. These cancel. We're going to do 7x divided by x. 7 and then multiply, so 7 times x. And 7 times negative 2. Change your signs. Add them together. Those cancel, and we're left with 16. We cannot divide 16 by x, so that's going to be our remainder. So we're going to do plus remainder over what we were dividing by. And here's our answer. Okay, now, same problem, and I'm going to show you the method of synthetic division. I'm actually going to do example 3, but I'm going to do it right here next to it so you can see the similarities. So synthetic division, we're going to take what we're dividing and we're going to change the sign. So it's x minus 2, I'm going to make it positive 2. Then I'm going to take my coefficients and put it off to the side. We have 1, 5, negative 7, and 2. Draw your line. This should look familiar, because we've done this before. We bring down the 1, multiply 1 times 2, add, multiply 7 times 2, add, we're adding negative 7 plus 14, multiply 7 times 2, and then add. So this, notice, is the same as our remainder, and then the 1, 7, 7 are same as our coefficients, 1, 7, and 7. So since we started with x cubed, our answer is going to be x squared. This last one's always going to be a remainder, constant, x squared, and then you would keep going x cubed, x to the 4th, so on and so forth. So we're going to write out our answer, 1x squared plus 7x plus 7 plus 16 over what we were dividing by. So same answer, 2 different methods. And that was example 3, and I just wrote it next to example 2 because notice they're the exact same problem. Okay, now we're going to do example 4 using synthetic division. So we're going to take what we were dividing, change the sign, do our coefficients. Here's x cubed, x squared, and then we're missing x, so we're going to use a placeholder, and then our constant. Bring the 2 down, and then multiply. 2 times negative 3, add, multiply, add, multiply, add. This is our remainder, then constant x squared. So our answer would be 2x squared minus 1x plus 3 plus negative 4 over what we were dividing by. So quite a bit easier than the long division, just a little bit faster too. Okay, so why do we even need to know this? Well, we have this thing called the factor theorem. A polynomial has a factor if and only if the remainder is 0. So when we're given one factor, we're going to find the other factors using the fact that the remainder is 0. So for instance, on example 5, it tells us x plus 2 is a factor, which means when we divide by x plus 2, we should get a remainder of 0. So we're going to do that. We change the sign, we put down our coefficients, and when we do this, this number right here should be a 0. So bring down our 3, 3 times negative 2, add, multiply, add, and multiply, and then notice that we do get that 0 remainder. So we have remainder, constant, x squared. Okay, now this says to factor completely. Well, we have one of our factors, it's x plus 2. Now we have another factor, because think about when you divide by something, your answer is a factor of what you divided. So we have 3x squared minus 10x minus 8. Now we have to check to see if we can factor this more, which we haven't done in a few units, so I'll remind you of how to do that. We would do first times the last, which is negative 24. And we want to know, are there any two numbers that multiply to give us negative 24 and add together to give us negative 10? So negative 12 and positive 2. And so we rewrite this using those two numbers. And then we're going to factor. GCF of the first two is 3x. We pull that out, we're left with x minus 4. Pull down that middle sign. GCF of the second two is 2. Divide that out, we are left with x minus 4. So we have what's inside and what's outside. And then we can't forget that original factor. Now this is a linear factor, can't factor more. Linear factor, can't factor more. Linear factor, can't factor more. And by linear, I mean the highest power is 1. Notice that our degree of our original was 3, and we have 3 factors. Not a coincidence. The most factors we could have is 3 because of that degree. All right, I'm going to go ahead and pause it there and upload this because it's already a pretty long video. I will look at examples, the rest of the examples in a later video. Thank you.